after end of that session, if you provide your G drive link, that would be helpful to us, because we will recapitulate this.
I'll try to solve all the questions which are there. Okay,
Okay.
which are
Uh,
as in the previous years. Most of them I will try to solve here in the class, and rest you can get it from the that gate books which are available previous years.
no, actually, I was talking about Google Drive link where we could access the material as well after
Okay, okay.
for
This
recapitulation.
that I'll share my YouTube channel where I'm uploading all the classes, so you can get it.
Okay, okay,
Wait,
okay. Thank you, sir.
I'll share my.
Sir, sir, share YouTube link, sir, so that we can access.
Okay, can you check this? Hello.
Yes, sir, we got it.
Okay. I'll share all the lectures in this channel only. Okay. Hello.
Okay, sir. Okay, sir. Okay.
Okay. So today, shall we start the class now? I don't think so.
Yeah, yeah, yeah.
If
I'm ready.
anyone will join, he can join it later because. Is there any another class from 7? Hello.
Yes, sir.
Is there another class from 7?
Yes, sir. Yes, sir.
Okay. Then we'll start right now. Okay. So here are the. I said that we'll solve the problems. So these are the gate problems only. So the first question we'll do. I'll give you 2 or 3 minutes. Uh, wait, wait. I have to first share my screen. Is my screen visible?
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Okay. Can you see my screen?
Yeah, perfectly visible.
Okay. So uh, this is the first question. I'll give you 5 minutes. You can solve first question. It is simple question which we have discussed in the previous class now for 7 formulas. Hello, hello,
Yes,
hello.
sir.
Yeah, I'm saying that the based
Sir.
on the 7 formula which we have discussed in the previous class, you can easily solve these 2 problems. These two both are the gate problems. The second one is the
Actually, we
common data type of questions. The data is common for these 52 and 53 problem. Question number 52, 53. So the data will be common for this. So based on the all the 7 equations which we have, I have in the previous class I have told you these 7 formula. You can solve these questions. So wait, I'll wait for you for the 5 minutes. After that, we'll discuss.
Sir, for first one is 10.8071.
Okay. Wait, just wait for few so that other can also answer. 10. What you have got? 10 point.
10.8071.
Okay. Hello.
Yes, sir.
Has any
Bring the
other?
next problem.
Okay, I'll do the second problem also. Then we'll discuss both the problem simultaneously.
So first one 108 kg per second.
Okay.
So for second problem, it's 24.8077%.
What is first power? We have said.
Answer is coming
Just say me the ABCD option. For 52, there are the ABCD. Out of which you are getting
A 24.8.
24 point. Yeah,
Thermal
yeah. Thermal.
thermal efficiency. Oh,
Okay.
yeah.
Okay. Hello.
Yes, sir.
Are you finished with both the problems? Wait, I'll have
Yeah,
to.
I did.
Okay, wait, I'll see. I'm getting many answers, I think so. No, no. So, shall I discuss now? If you have done?
Yeah, sir.
Okay. So, first problem. Question number one. What they have given that Brayton cycle they have given. So, That is 1, 2, 3, 4. Okay. So they have given that air and enters at a pressure of 1 bar. Hello.
हाँ सर सुन रहा हूँ.
They have said that air enters at a pressure of 1 bar and exit at a pressure of 8 bar. Okay. The inlet temperature T1 of the air is what it is given 300 Kelvin. Okay. And the maximum temperature is after the heat addition. So it is 1280 Kelvin they have given. Okay. So they have given that heat addition, that is heat addition Q32. Heat addition is taking place at constant pressure here. Okay, so they have given that it is 80 megawatts. Okay, so can we change that into watts? So 80 into 10 to power 6 watt. What is watt? Watt is equals to joule per seconds. Okay. Hello.
Yes sir.
Okay,
Sir,
so we'll, yeah. Hello.
Yes sir, you are audible sir.
Okay, so this we can write like this Q32. Okay.
हाँ sir.
Okay, now what we have given that first for Q32, we can also write Q32 as like this m m dot, because mass flow rate we have to calculate Cp. Previously we were discussing each and everything in the derivation for per kg of mass flow rate. Now because here we have to determine the mass flow rate, so here we have to also multiply with m dot. Okay, so mCp into T3 minus T2. Is it okay? Where Cp in the question they have given 1.005 kilojoule per kg Kelvin, which we can write 1005 joule per kg Kelvin. Is it okay?
हाँ sir.
Okay, now what is given in the each and every data? Suppose we are having for the question. So Q32 is 80 into 10 to power 6 joule per second is equals to uh, m dot we have to calculate. Okay, Cp they have there is 1005 joule per kg Kelvin into temperature T3 minus T2. Here T3 we know already. T3 is the maximum temperature 1280 Kelvin. We have to only determine T2. So how we can determine T2? We already know that T2 upon T1 is equals to pressure ratio to the power gamma minus 1 upon gamma. Is it from the those formulas? Hello?
Yes, sir.
Okay.
Yes sir.
So temperature T2, T1 temperature is already given 300 Kelvin. Okay. And what is the pressure ratio? 8 divided by 1. Gamma value they have given 1.4. And P2 they have given 8 bar. P1 is 1 bar. Okay. So here we can write 1.4 minus 1 upon 1.4. So T2 upon 300 is equals to 8 into 0.4 divided by 1.4. So what we will get here? From here we will get T2. We have to just multiply. So here we will get T2 is equals to 543.43 Kelvin. How many of you have got this answer? T2? Hello? Actually, I can now
Yes
send.
sir. Got it. Got it sir.
Got it. Now just we have to
Yes sir.
put this value here instead of T2. Okay. So what we can write here, 80 into 10 to power 6 joule per second is equals to m dot into 1005 joule per kg Kelvin into What is it? 1280 minus 543.43. Okay, we'll go to the next page. Wait. Okay, so here we can write 18 to 10 to power 6 joule per second is equals to m dot into 1005 joule per kg Kelvin into 1280 minus 543.43. It is in Kelvin, so Kelvin will cut out. Okay, joule will cut out. So what is in the question they have asked? They have asked mass flow rate in kg per second. Okay, so when we will rearrange this, 80 into 10 to power 6, so kg will come here. Okay, it will come here, cross multiplication. So final unit will be what we will get, kg per second. Okay, is equals to m dot and divided by 1005 divided by 1280 minus 543.43. So what we will get for m dot 108 108.719 kg per second. This is the correct answer. Okay, have you got this?
Yes, sir.
Yes, sir.
Yes, sir.
Is it okay for everyone? We have
Yes.
just followed all these, only those 7 formulas has been utilized. Only the one thing which here has been addressed, m dot, because previously during the derivation time we were discussing that we are considered for only per unit, per kg of mass flow rate, kg per second of mass flow rate. Therefore m dot we were taking 1. So now m dot we have to calculate. That's why we have to also multiply this here, because here it is no longer we are talking about per kg. Okay, now we'll discuss a second question. Okay, hello.
Yes, sir.
Okay, now we'll discuss question number 2. Okay, so in this question what they have mentioned, that in a simple Brayton cycle, pressure ratio, that is rp, they have given 8, and the temperature, the entrance of the compressor, that is T1, and the turbine T3 are 300 and 1400 Kelvin respectively. Both compression and gas turbine have isentropic efficiency equals to 0.8. For gas, for the gas, assume a constant value of Cp equals to 1 kilojoule per kg Kelvin, and ratio of a specific heat, that is gamma 1.4. Neglect changes its kinetic energy and all those things. So the power required by compressor in kilowatt per kg of gas flow rate, here they have talked about per kg of gas flow rate. Okay, so m dot we have to take 1 kg per second. So second question they have asked thermal efficiency. Okay, we'll do this problem now. Question number 2. 1 2 3 4. So what they mentioned, that is pressure ratio rp, this is equal to p2 upon p1 is equals to 8 they have given. Okay, and temperature at inlet is 300 Kelvin, and at the exit of and the what they have given, at the entrance of compressor and turbine, compressor is 300 Kelvin, and the entrance of turbine, it is 1400 Kelvin. Okay, so m dot they have also given 1 kg per second, because in the question they have asked here, they give gas flow rate for per kg gas flow rate, that is m dot they have already given. So CP they have given, and isentropic efficiency also they have given. Isentropic efficiency of compressor and turbine they have given 0.8. Also they have what they have given, that is gamma they have given 1.4, and CP they have given 1 kilojoule per kg Kelvin. Okay, this only they have given, I think. Yeah. So they have asked power required by compression and thermal efficiency of the cycle. Okay. So for what they have asked, power of the compressor, and second efficiency of cycle. Okay. So what we have to do, let us solve second part first. Okay. What is the efficiency of the Brayton cycle? We have discussed 1 minus 1 upon rp to the power gamma minus 1 upon gamma. Okay. So 1 minus 8 to the power 0.4 upon 1.4. Is it okay? So what you have got for this part 2? Hello? What you have got the thermal efficiency of the cycle from the
24.8.
oh,
24.8.
okay.
A.
So it will come 24.8. All you have got all of you have got this only, na? Hello?
Yes, sir. Yes, sir.
Okay. Now we have we'll discuss about the that first part, that is the power required by the compressor. Okay, because here in the question they have mentioned about the isentropic efficiency of the compressor and the turbine. So the cycle will change like this, we have previously discussed also. Okay, so in which is the compressor part, 1 or 2 or 3 or 4, which is the compressor in this cycle?
1 to 4.
Okay, so what will be the power consumed by the compressor?
H2 minus H1.
H2 minus H1 or H2 dash minus H1?
Yes, sir.
H2 dash minus H1, which
Yeah,
is 0. Which is actual H2 minus H1 divided by 0.8.
yeah, you are right. So we'll discuss that also. Okay, so here power we'll discuss.
Hello, sir.
Yeah,
Hello.
yeah, yeah.
Sir, efficiency by this formula 44.79%.
Okay, actually
Yes, sir. I'm
I haven't calculated it. The person was saying, that's why I have
Hello.
written that directly.
44.8, sir.
44.8, sir. I'm getting.
Okay, wait, I'll calculate and tell you. Yeah, you are right. It is 44.8. The person who was saying 24.8, please check it. I think you have made the wrong calculation. It is actually 44.8. Okay. Now power of compressor, what it is, that will be m dot into Cp into H2 dash minus H1. No H2, wait. It will be m dot into Cp into T2 dash minus T1. Is it okay? Now what we have given in the question, isentropic capacity of the compressor. So what we have, what is the formula for isentropic efficiency of the compressor? Hello?
H,
H2
H2
minus
minus
H1 by
H1.
0.8.
It was H2 minus H1 upon H2 dash
H2
minus.
dash minus
So
Yes,
H1.
sir.
this we can write like that also, na? T2 dash minus T1, because MCP will cancel out each other and we can directly write like this. Okay. Now T2 upon T1 is equals to Rp to the power gamma minus 1 upon gamma. So T2 upon T1 300. So Rp 8.4 upon 1.4. What we will get? T2 is equals to 543.43 Kelvin. Will we get? Have you got? Because it is similar like in the previous also. We have calculated this. So it will be similar to that only. After that, isentropic efficiency of compressor we have been given. So it will be T2 minus T1 upon T2 dash minus T1. So which we can write like that. 0.8 is equals to T2 is 543.43 minus T1 300 divided by T2 dash we have to calculate minus T1 300. So what you will get that T2? Can anyone tell me?
604, sir.
Wait.
604.28.
28 Kelvin.
Yeah, 604.3. We can write 604.3 Kelvin. Is it okay? Now just we have to put this value here. So we will get the power of the compressor. What it will be? M dot V, it is given 1 kg per second. CP they have given 1. Just write the units also. Wait, kg per second into 1 kilojoule per kg Kelvin into what is the temperature? 604.3 minus 300, that is Kelvin. So what will it? Kelvin will cut out, kg will cut out. Okay, so joule per we'll write this. So what it is? 604 point what you have got? Can anyone tell me?
304.28. 304.3.
Okay, 304.3
Kilojoule per kg.
kilojoule per second. Okay,
Okay. जी.
so which we can write 304.3 kilowatt. Joule per second is watt. So have you got that? 304.3 C is the answer, because they have asked per kg. So that is 1 kg per second. So that won't change the problem, because it is they have only asked per kg. So answer would remain same, that we have calculated in kilowatt. Okay.
Hello.
Yeah.
Sir, regarding efficiency,
Yeah.
the formula which we use to calculate the efficiency, it is for ideal cycle. But here, we can't assume it is ideal cycle, no, sir, because it has been given that the isentropic efficiencies are given.
Isotropic efficiency. Wait.
So we can't use that formula. It is for ideal cycle.
That I have to check actually right now.
Sir,
From
efficiency होगा
20,
work of turbine by Q in.
Hello.
Sir, efficiency क्या होगा? Work done by turbine by Q in.
Yeah, that also you can write. Yeah, work done by you can write it like 1 minus. Wait, there are several form you can write. Work net upon Q supplied, or Q net upon Q supplied, or 1 minus Q rejected upon. These are the different forms of formula which you can write efficiency. Hello.
Sir, work of compressor has not to be included in this. Like work net minus work of compressor by Q in ये सही
No,
ज्यादा रहेगा या यही?
not there. There. Wait. You can use this formula. I think this will be more easier for you. That also you will get the same answer in all these formulas. Okay.
Okay, sir.
Uh, Wait, we can check also in that because I haven't calculated this. I'm calculated directly in the class. Okay, so we can also calculate this by actually. Can you tell the girl name who was saying that talking about that? Hello,
Priyanka, sir.
Yes, sir.
yeah, Priyanka. What is the answer you have got?
Yes.
The initial answer which was told 24.8.
Okay,
Yes, sir.
okay. Wait, then we have to calculate that also.
यही है.
Okay, okay.
हाँ, हाँ.
So efficiency 1 minus Q rejected upon Q supplied. Okay. So Q rejected will be how much uh, for the cycle, because we are having both the efficiencies.
T4 minus T1.
Yeah, 3, 4, 4 dash, 1, 2, 2 dash. So here we will get T4 dash minus T1 divided by, yeah, I think it will change. Sorry. So T2 dash minus T1. We have to calculate these two. So T2 dash we have already calculated now 604.3. Now just we have to calculate T2 T4 dash only. So what was the formula for that? Uh, T3 upon T4 is equals to Rp to the power gamma minus 1 upon gamma. So T3, what it is given in the question T3? T3 given for,
1400.
okay, 1400 upon T4 is equals to 8 into 0.4 upon 1.4. So what was the value of T4 you were getting?
772.
0.86.
0.86 Kelvin. Okay. Now this we have to put in that turbine. That is what is the turbine? Can any
0.8.
what?
0.8 efficiency.
H4
Yeah, S3 minus H4.
divided by S3 minus H4 dash.
No, no, no. S3 minus H4 dash, because this is higher and this is higher also, so difference will be lower. Okay.
Oh, okay, okay, sir.
S3 minus H4. So this you can write T3 minus T4 dash upon T3 minus T4. So can anybody tell me what the value of T4 you have got? Because T3 will be 400 minus T4 dash, and T3 400 minus T4 dash 772.86 Kelvin. So what is the T4 dash you have got?
898.24.
898.24 Kelvin. Okay. Now just these put these values in this value in the above this equation. You will get the answer. We'll check that. 898.24 minus T1 is 300 divided by T2 dash what we have got 604.3. 604.3 minus 300.
24.75 आ रहा है सर.
Yeah, wait, I'll have to also check.
So denominator
Heat reject.
सर ये
denominator
डिनोमिनेटर में 1400 माइनस 604.9 होगा.
What?
डिनोमिनेटर में 1400 माइनस 604 होगा सर.
Yeah. Denominator.
इन एफिशिएंसी, फाइनल एफिशिएंसी में. क्यू
Denom
इनका तो T3 माइनस T2
yeah.
डैश है ना.
Wait. Yeah, I have written wrong. I think here. Here I have written wrong. Na? It is T3 minus T2 dash. Is it okay now?
हाँ
yes
सर, अब
Yeah.
अभी भी सही नहीं है सर.
No, it is now right now. Heat rejected will be T4 dash minus T1.
सर 1400 माइनस 604 नहीं होगा.
Yeah, this here we will change. Na? Here formula only I have written wrong directly. So that's why. Here we will change completely. Wait. Here what we will write, that will be T3 minus T2 dash. Okay, so T4 what we have got, 898.24 minus 300, and T3 what is the T3, 1400 minus
1404
6
04.9 कुछ.
yeah 604.3. I thought we got 604.3. So now we will get the answer correctly. 898.44 minus 300. Have you got, all of you have got the same answer actually?
यस सर.
Yes, sir. 24.8%.
Okay. 24.8, yes. So this will be the answer. Previously 24.8 will be the answer. This is the right answer. Okay. Now we'll solve some more problems and then we'll go to that part, regeneration. So what is the time right now?
647.
Okay,
647.
we can solve one or two more problem. That will be directly on these formulas only. Because this type of questions only they ask, like this problem only. Both answers were coming in the like 44.8 option was also there. 24.8 was also there. Wait, I'll give you that question. Wait, I'll write because this question it didn't got that, so I'll write it. Okay. Air. Should I directly write the that data, or should I write the whole question?
सर
What do
डाटा
you?
काफी रहेगा.
Okay, so I'll draw that diagram and mention all the parts. Okay. So in a Brayton cycle, what they have given that air enters at a pressure of 1 bar and a temperature of 27 degrees Celsius. Okay, it is then compressed to a pressure of 6 bar. Then find the efficiency of this cycle. Efficiency you have to find. Okay, and the maximum temperature you also have to find. If what is given, if turbine work is equals to 2.5 times of the compressor work. Okay, so you have to find these two things. Okay, and the data is given here. So please solve this question also.
Sir, A oriented, so can we take gamma is equal to 1.4?
Yeah, just take one wait. I'll write that also because many of you might have been confused. That gamma take 1.4 and CP if you have asked at just take 1.005 kilojoule per kg Kelvin. Here it is mentioned that it is 27 degrees Celsius. Okay, we're not able to see. Hello, has any one of you got the answer?
Tmax RF 1251.4 Kelvin.
40% sir efficiency.
Okay, and efficiency what you have got?
40%.
Okay, both of the answer are correct. Now we'll solve the problem. Okay,
सर एक बार आंसर दोबारा बता दीजिएगा.
1251.4 Kelvin. That is the T3 maximum temperature. Okay.
Okay sir.
Okay, so 1, 2, 3, 4. Tmax they are basically talking about T3. Okay, they are asking T3 in this question. T3 is the maximum temperature, not the efficiency.
40%.
Yeah. So first part we will do that is efficiency. Efficiency we can directly calculate because here nothing is mentioned about that efficiency, isentropic efficiency. So we can directly use this formula. So 1 minus 1 upon 6 divided by 1 to the power 0.4 upon 1.4. So here you can directly get 40%. Okay, it is simple. The second part is a little bit tricky. Okay, so second part they have asked about the Tmax is it or T3 temperature. Okay, and what they have given that turbine work should be 2.5 times of the compressor work. Okay, so what we have read in the class that ratio of the compressor work upon turbine work, what we call that it as back work ratio, no? So
Yes,
basically,
sir.
they have given the back work ratio. Only the method they have changed to write the back work ratio. Is it fine for you? Or you can, if anyone don't know about the back work ratio, then also he can easily solve the problem by putting the data here. Okay, just for your knowledge point of view, I have to tell you about this thing. Okay, so T1 they have given 27 degrees Celsius, so every thing we have to write in Kelvin. Okay, so 273 plus 27 is equal to 300 Kelvin they have given of the entering air temperature. Okay, so from this identity we can directly calculate T2. So what you have got T2 from here, because the pressure ratio is given 6. Okay, gamma it is mentioned 1.4, T1 is 300 Kelvin. So by putting all this value in this formula we can get T2. What is the value of T2 you have got?
505.
500.5 Kelvin.
Okay, okay, now what they have given, they have given in the problem that turbine work is equals to 2.5 times of compressor work. Okay, so what is the turbine work here? We can write turbine work as S3 minus H4 is equals to 2.5 times of H2 minus H1. Is it fine?
Yes, sir.
So if we are assuming for per kg of the air entered, so we can directly Cp into T3 minus T4 is equals to 2.5 times of T2 minus T1 into Cp also. So Cp will cancel out each other, because it is we are talking about air only. So Cp for both air will remain same. So from here we can directly T3 minus T4 is equals to 2.5 times of the T2 minus T1. So T3 we have to calculate. Okay, and T4 what is it? T4 also we didn't know. So 2.5, T2 we know 500.6 minus T1 300. So what we will get from here? Hello?
501.5.
500 1.5 na?
Yes, sir. 1.5.
Okay, now we again know from this formula T3 minus T4 is equals to Rp to the power gamma minus 1 upon gamma. Is it? Because we are talking about the isentropic process. For isentropic process, this is the identity. Okay, formula which we use. So T3 upon T4 is equals to 6 to the power 0.4 divided by 1.4. Is it? So this we can write equation 1, and what we can get from here, can anyone tell?
1.668.
What?
1.668.
Okay, 1.6685. Okay, so T3 we can write 1.6685 into T4. Is it? Now we can put equation number 2, put equation 2 in 1. So what we will get? 1 point, this is 1.6685 T4 minus T4 is equals to 501.5. So 0.6685 T4 is equals to 501.5. So what we will get? T1, T4. Hello, what you have got? T4
150.
750 na?
750.6.
750, sir.
750 Kelvin we can directly write. Now we will put that in the equation number 2. So we will get
1251.
we'll get directly here 125
11.
1.6 Kelvin. Okay, so everyone has got. Hello.
Yes, sir, done.
Okay, so this type of question only they will ask in the exam. Okay, so quickly we can do one or two problem. One or two can we do, or should we stop here only, or we can discuss in other class? What do you want?
Sir, now one more class is there, sir.
So okay, so we'll okay, so we'll stop here only, and uh, uh, we can if anyone have problem in the question discuss, you can you are feel to free. You can ask me right now. Hello.
Sir, second last slide.
No
Second one.
question.
Okay.
So share your email ID.
Mm, I have already shared my channel. Okay, I'll share my email ID also. Wait. I'm sharing both my email ID, my personal also, and my uh, college mail ID also.
If there is any doubt, you can clarify now, sir, in through
Yeah,
email.
yeah, yeah. You can. You are free. I'll share my number also. Okay.
Okay, thank you so much, sir.
This is my
Thank you, sir.
This is my personal mail ID. This is my college mail ID, and my number I am sharing. This is my mobile number. This is my WhatsApp number also. So if you are having any problem, you can write me on the WhatsApp. If I will not answer, then you can call me. Okay.
Okay, sir. Thank you, sir.
Okay.
Okay, sir. Thank you.
Thank you, sir.
Okay.
Bye, sir.
You can follow this channel. I will be sharing all the classes here only in this channel.
Okay, sir. Okay.
Okay. So from there you can see each and every classes which are happening. Okay. Okay. Okay, then we'll discuss more some more problems, and then we'll go to new topics like regeneration, reheating. Okay,
Sir.
Okay, sir.
Thank you, sir.
okay, thank you.
Thank you, sir. Bye.
Bye.